All right, I think it's 1 minute of two, so I guess we'll get started. Welcome to the Beginner's Guide to Spring Cloud. Did someone pay you guys to come or something like that? Like, I have never spoken to a full room and have people standing up before, so that's absolutely awesome. I appreciate everyone coming. So I hope you guys are going to learn a lot today, and I hope we'll have some fun. So there's some demos and stuff. First, a little bit about me. I am a rookie engineer on the Spring Cloud team. I recently joined Pivotal about 7 or 8 months ago. So yeah, I'm pretty new. Before that, I worked for IBM, another very small company. But I did a lot of stuff with Spring Cloud and used it, and I thought it was really cool. And eventually, my teammates reached out to me and said, "Hey, do you want to join the team?" And I said, "Sounds like a good idea." So if you want to get in touch with me, I'm at Ryan J. Baxter on Twitter. You can check out my blog, ryanjbaxter.com. If any of you are wondering what I'm doing in that picture, I like to do masochistic stuff to myself and race and do obstacles and various things, carry buckets of rocks miles uphill and whatnot like that. So at the end, they let you jump over a fire and you get a nice little picture out of it. But yeah. So a little bit what we're going to do today. We have 50 minutes. There's a lot to cover. I'm going to try and get some demos in there. We're going to get some demos in there. But we're going to talk about a little bit about Spring Cloud, the background there, why we think it's useful, what it's all about. Talk about some of the key projects. And then we're going to do some demos with Spring Cloud and then hopefully leave some time for some questions and wrap it up with that. So first we have a survey. So I assume that since you're at this conference, you are all used Spring in some way or another. But has anyone here ever used Spring Cloud before? Okay. And I don't know why you guys are all here then. Shouldn't you guys all be experts? What the heck? Is anyone using it in production today? Running production apps? Okay, you guys definitely shouldn't be here. How is it running in production? Okay, one last question. Does anyone know this guy? One of my colleagues, Josh Long. Has anyone ever seen him give his cloud native Java talk before? Has anyone left that talk and thought, wow, he made that look so simple, it's so easy, I can't wait to get home and get started doing this, and then you whip up your IDE and you go to start.spring.io and you're like, what the hell did he do? Anyone ever had that experience? I know when I didn't work for Pivotal, I saw Josh give this talk, and I was super excited about going back to my office and doing the stuff that he did, and I had the same exact feeling as you guys. So that's where I kind of came up with this talk. Because I remember starting out using Spring Cloud when it was just the Spring Cloud Connectors project. And now there's a lot of different projects under the Spring Cloud umbrella. And knowing what they all do can be kind of daunting when you first get started. So our ultimate goal is to be like Josh Long. So why Spring Cloud? I think in general, we can all agree that when you're building applications for the cloud, following a cloud native pattern is good. Building 12-factor apps is good. It works well in the cloud. And it's very easy for large corporations like the one I used to work for, IBM, Google, Facebook, Netflix, Amazon. It's very easy for them to build these applications, right? They have the money, they have the resources, they have maybe not the time, but they have enough power to put behind these things to build these type of applications. What about the little guys, right? The people who don't have that type of backing and those resources. And the other thing that kind of inspired Spring Cloud is that there's been a lot of companies that have had success doing this. They've open sourced libraries and tools for you to use to build cloud native applications, but getting started can be a little daunting with them, right? They're kind of just rough tools. You have to do a lot of work to get them working. So following kind of the model behind Spring Boot, where it's very easy to get started, we're opinionated, but allow you to easily configure things afterwards. We came up with the Spring Cloud project, right? And Spring Cloud easily allows you to do things that are very similar in Spring Boot, but for cloud native applications. Another cool thing about Spring Cloud is we don't really care where you run your application. You can run it on your local machine, you can run it in Pivotal Cloud Foundry, you can run it in Google Cloud, AWS. I don't really care where it is, because at the end of the day, it just boils down to a jar that you do java-jar and it runs, right? So that's pretty cool. So some of the Spring Cloud components here. We're going to talk a lot about almost all of these today. You know, we're going to talk a lot about configuration. Where is your configuration stored when you're building cloud applications? How does Spring Cloud help you with that? Service discovery, if you're not familiar with this term, basically means how do other services, microservices in your cloud native application talk to each other, find out about each other, where are they located? That type of stuff is all handled by service discovery. I'm not going to sugarcoat anything. Your applications will fail in the cloud. It's not some magical environment where nothing ever goes wrong. And one of the ways we deal with failures in the cloud and prevent them from cascading into monstrosities that cause millions of dollars of outage and revenue is with circuit breakers. So we'll talk a little bit about that. Routing and messaging is important. Obviously, you're going to be communicating between the various microservices in your cloud native application. So routing messages, API requests, et cetera, are all going to be important things. API gateways are generally important. Even if you're not exposing a public API, you probably have some application that you're building that's going to be using the APIs of your cloud native application, and it's probably a good idea to put a gateway in front of that. Something that people don't often think about until they start running into a problem is tracing. So how do you visualize or trace a certain request that might touch an exponential number of microservices, right? You may have one request coming into your application that might call 50 different applications behind the scenes, right? How do you trace that request through that entire tree? And then CI pipelines and testing. We're not really going to cover that one too much today. I'll talk a little bit about it. There's 2 new projects there that my colleague Marcin has been working on that are really important, really cool, but we're not really going to see it in detail today, but we'll talk a little bit about it at a high level. And yes, there's much, much more to Spring Cloud, right? We have projects, Spring Cloud Bus, Spring Cloud Stream, Spring Cloud Data and Task, Spring Cloud AWS, and a whole bunch more. If you go to github.com/Spring Cloud, you'll see all these here, and you'll be like, what do they do? The good news is that many of the other ones also have talks at the conference today, either later today or tomorrow. And they'll deep dive on some of these things like Stream and Task. So look out for those. So I'm not going to cover those in detail today because there are other talks at the conference where you can go to if you're interested in those. But yeah, there's a lot more too. Okay, so let's get started with some of these things. Configuration. Typically Spring Boot, you have your application.properties or application.yaml file inside the application. That's all well and good, but in the cloud, it's better to centralize your configuration and move it out externally from your applications and have it be stored and be able to access across all environments. So let's take an example. You deploy a number of microservices to your environment. Something goes wrong. You want to change the logging level of that. You don't have to go into every single application, change the logging level, and then redeploy these apps, right? With Spring Cloud, the Spring Cloud config server, you can change the configuration in the config server and without having to redeploy the apps, have those changes applied to all the applications that are already deployed, right? So the config server is backed by, you have a couple different options for backing it. You can use Git, SVN, you can use a native file system, or even Vault to store config. You can actually also use Console and Zookeeper as well. In the compliance, your microservices will actually retrieve configuration from the config server on startup. And they can even be notified of changes, right? You can actually push notifications to these applications saying, hey, there's changes in your configuration. You might want to refresh and pull those new changes down. So that's a nice little feature as well. So service discovery, I touched on this a little bit. The dynamic nature of cloud native applications, you need to be able to discover microservices in kind of a more dynamic fashion, right? The URL of a service today might not be the URL of a service tomorrow. you might have 5 instances of a specific application deployed. Tomorrow you might have 1. The next day you might have 100, right? How do all the other microservices in your cloud native application know what's going on? And this is what Service Discovery does. Service Discovery provides information to your entire cloud native application about where everyone's located and how many instances there are, etc. So to do this, we actually borrow a little bit from some other open source projects, namely Netflix, Eureka, Zookeeper, and Console. Routing and messaging, this is probably one of the key concepts in Spring Cloud. I think is one of the coolest things. It integrates alongside with Service Discovery, so the information that each microservice gets from the Service Discovery registry allows us to route specific messages to other services. And you can do this via HTTP requests or messaging as well. There's actually a built-in client-side load balancer. So instead of deploying some other thing in your infrastructure to load balance requests, you can use a client-side load balancer, which is going to route the request accordingly for you. Again, using the information from the Service Discovery service. And we use Netflix Ribbon and Feign to do some routing and messaging. We also, for HTTP requests, for messaging, you can use RabbitMQ or Kafka as well. API gateway. It's likely, or it's probably, actually, your cloud native applications are going to have some type of API. Whether you have external consumers of that API or not doesn't really matter. You're probably going to want to use an API gateway so you can shield the client application from the services behind the gateway. This allows you to continue to change your environment. Maybe you take one microservice and you end up splitting that up into 2 microservices, or you scale microservices up or down. The clients become unaffected by this because the API gateway is the thing routing all the requests to the correct services. And the API gateway, again, takes advantage of the service registry from the Service Discovery service to know where these services are and how to locate them. So here we use Netflix Zool project to do that. We're also working on a new gateway service, which is actually out there in the Spring Cloud Incubator, which will kind of be the next revision of that of our gateway sometime soon. Circuit breakers, like I said, failure is inevitable in cloud native applications. Trying to mitigate these failures is critical. So for example, if you have a bunch of different microservices, and they have a huge dependency tree between them. Service A depends on B, depends on C, depends on D, etc. If the service at the end of that chain, service D, for example, starts behaving badly, is slow, etc. Right? So if a call to service A makes a call to service B and call to service C, and service D is the one having a problem, guess what? All those services are now going to have an issue, right? Because up the tree, everything is going to start having problems and acting slow because it's waiting for service D to actually respond to a request, for example. So what you can do is protect these boundaries by what's called a circuit breaker. So if service D starts to slow down and requests start timing out, we can trip a circuit breaker and say we're not even going to bother talking to service D because service D is having issues, he's screwed up, I'm going to leave him alone, and I'm just going to return baby back some cache data instead from the last good request I got. And this helps prevent cascading failures throughout your application. So we take advantage of another Netflix project called Hystrix to provide these circuit breakers. We're not really going to see this in too much detail, although it is there under the covers and some of the stuff we're going to do today. But I actually have an interesting blog post on this on my blog if you want to check that out for more information. Tracing. Tracing, like I said, is critical, and you actually don't really realize it until your cloud native applications become fairly complex, and you start needing to trace requests down this dependency tree of where things are happening. So we have two projects that help you down this path. One is Spring Cloud Sleuth, which actually does kind of all the magic. It allows you to trace a request from one service to the next, to the next, to the next. And then Zipkin, which is going to provide a nice little UI for you to visualize these requests. We also have support here for using things like Elasticsearch, Logstash, etc., for going back and looking and pulling out logging data that you may have happened weeks or months ago and doing complex searches and stuff like that. And then the last thing that I want to talk about just quickly is CI pipelines and testing. So from a testing point of view, you have all these microservices. They're going to be communicating with each other. But now, you obviously want to run, integration tests or JUnit tests, et cetera, to test these things. But you don't want to have to spin up your entire environment to do that. So there's a project under the Spring Cloud umbrella called Spring Cloud Contract, which allows a consumer of an API and a producer of an API to agree on a contract. The producer is going to publish that contract. The consumer is going to consume that contract. And when the producer changes something and republishes its contract, the consumer will automatically break or successfully pass with their unit tests on that. This is a really great tool for doing testing. I highly suggest you take a look at that project if you're going to be building cloud native applications and have a number of microservices. The other project here is for building pipelines, right? You're going to want to automate your deployments, your testing, everything about your applications. So it makes sense to have these pipelines. So in your CI server. So what we have a project called Spring Cloud Pipelines, which allows you to, it's kind of an opinionated way to automatically generate a pipeline for a specific application that will do everything from building that application to testing it, doing integration tests, end-to-end tests, deploying it to testing environments, staging environments, and then ultimately deploying it to a production environment. And that integrates with both Jenkins and Concourse. So that's another fairly new project. So I suggest you guys check that out as well. We're always looking for feedback in other ways people are going to want to use these stuff. So check that out as well. But we're not going to be talking too much about that today. All right, so that brings me to the demo portion of the slides. So what are we going to build? So I'm going to build an application that's extremely simple and dumb because I find those to be easy to understand at least. So we're not distracted by what the application is doing. We're trying to learn about the concepts, right, and the tools. So this application is going to basically produce a greeting. It's going to say, hello, Ryan. I can change the name if you want. Or I can change the greeting to be Ola or whatever. I don't care. But it's just going to produce some type of greeting. And there's going to be 3 services or 3 microservices, if you want to call them that, that's part of this application. There's going to be a service that produces a name. There's going to be a service that produces a greeting. And then there's going to be kind of a front-end service that takes those 2 services, combines them together, and displays the greeting that we're going to see. So very basic, very simple stuff. But we're going to end up using a lot of the stuff we just talked about to do this. So before I get started, there's one other thing I'm going to talk about quickly. Lots of times, so some of the things we talked about today, we talked about service discovery, we talked about the config server, we talked about Zipkin. Now these 3 things and other things that you might be using in your cloud native application are kind of like infrastructure pieces. They're actually pretty much going to be the same no matter what application you build. You're going to have a Eureka server or whatever, some type of service discovery server. You're going to have a config server, and you're going to have a Zipkin server. And if I was to build an application for that every single time, I'd drive myself insane. So we have this tool called the Spring Cloud CLI, which allows you to spin up kind of infrastructure pieces on your local machine. It's more of a development tool to just bring up those pieces, right? Because there's no need for me to go out and build an application just to start a Eureka server or to start a config server. So we have a CLI tool that's actually an extension to the Spring CLI. So you install the Spring CLI, and then you go ahead and install this extension, which is just a jar file called the Spring Cloud CLI, and then you can easily bring these things up. So Is that too small for everyone? Does it need to be bigger? Good? Okay. So if you want to use the Twitter, if you want to use the Spring Cloud CLI, you say Spring Cloud, and then you say what things you want to spin up, okay? So I'm going to want to use the config server. I'm going to spin up a Eureka server, and I'm going to spin up Zipkin as well, okay? And all I got to do is do that, and magically the Spring Cloud CLI is going to start those 3 applications for me, okay? Now, the one caveat here you might be wondering is, well, this config server needs to be backed by, where's it getting its configuration from? And I need to tell it, what is it pointing at, a Git repo or a subversion repo or local file system, et cetera. Well, you can actually configure each one of the things you spin up by placing or creating a YAML file. Oops. That's right. Okay. So you create a YAML file, and you basically specify the configuration for the config server here. So I'm just saying, hey, I'm going to use a Git server, and my Git repo is actually this Git repo here on GitHub. Okay, so that's where the config server is actually going to pull its configuration information from. And if we just quickly take a look at that repo, it looks like this. It's very simple. It has 3 properties files in it. Actually, the application YAML property, which is going to be applied to all services, is going to be applied to all services that we serve from this or pull the configuration from this config server, is empty. So there's nothing even going on there. The greeting.yaml for the greeting service, it just specifies the port, and then the greeting that we're going to use, which as you can see there is hello. And then same thing with the name service, it's going to specify the name, the port, and then the name we're going to say hello to. All right. Very simple stuff, nothing complicated going on, but this is where it's pulling its configuration from. So just to confirm everything's up and running, if I go to localhost :888 and I try to pull the configuration, say for the greeting service, we'll see it return back some JSON to me that basically is the configuration we were just looking at, right? Okay, so our config server is up and running. We'll also check out Zipkin, make sure that's up and running. Oh, that doesn't look too pretty. Like that, and then we'll also make sure that the Spring Cloud CLI started up Eureka. So Eureka is running here, and we see that Eureka is up and running, okay? So again, I was able to spin that stuff up very quickly and easily, and again, these are just infrastructure pieces that are going to look exactly the same for most applications. This tool is very convenient for doing development, so I suggest you take advantage of it when you start building your applications with Spring Cloud, okay? All right, now onto the coding piece. So let's start by creating the greeting service. So I'm going to use the Spring initializer just from IntelliJ. Again, you can go to start.spring.io if you want to, but I just like it because it's integrated in my IDE. So if I start to spring.io, we're going to call this the greeting service. Okay. And obviously, I think everyone's familiar with start.spring.io, right? How it works. They know. Okay. All right. So I'm going to pull in the web starter. I'm going to pull in the config client, the Spring Cloud config client, because I'm going to pull some configuration down. I'm also going to add Eureka discovery, right? So Eureka, so I can get information from my Eureka server and also publish my own information to Eureka. I'm going to pull in sleuth because I'm going to do some tracing, and I'm going to pull in Zipkin because I want to send that tracing information off to the Zipkin server as well. So those are my dependencies for my app, and that was all fine. So the first thing we're going to do that everyone should do, no matter what app they're building, is give your application a name, because who doesn't want to have a name for their application? All right. So spring application.name, we're going to call this greeting. This is actually a pretty important piece, right? Because it does 2 things. First of all, it's going to tell, the config server is going to use this name to pull down the correct configuration. You'll notice that the name I gave it here matches the greeting.yaml file, right? That's how it knows to pull this configuration file down and use this configuration file for that service, okay? The other important thing this is going to do is this is going to be the name that my application registers with Eureka with. if that makes sense. So it will say, you know, I am the greeting service and I am located here. This is my URL, okay? So that does two very important things. So that was the easy part. Now the fun part. Is that too big or not big enough, or you can see that? Everyone's good? Okay. Just holler if something's wrong, especially if I screw something up coding and you notice it and you just don't wait for me to fail. Okay, that's the worst thing. So we're going to start by adding a couple of annotations here. So we're going to make this a REST controller, and we're also going to tell this application to register with Eureka, and you do that just by adding an annotation. So we're going to say enable discovery client, okay? And that's basically going to now register that application with Eureka. The other thing we're going to do here is pull in the greeting from our configuration. So we're going to just add an @value annotation, and we're going to say pull in the greeting property, and we're just going to assign that to a string, greeting. And the other little small piece we're going to do here is just create a logger. So private static final logger, we'll call it log equals new logger dot get logger greeting application dot class dot. I love huge font, right? Because this is just going on forever. Okay, so you're going to trust me that that actually does something great. And the final thing, or the next thing we're going to do here is just create an API to get the greeting, right? So we're going to say at request mapping, and this is going to be a public string. We'll call it get greeting, and return greeting. Okay, so nothing really fancy going on here. I'm sure everyone's familiar with this at this point. We'll also go ahead and log the greeting, okay? Just to make ourselves feel comfortable that things are working. I love good logging. And then the final thing we're going to do here is we need to provide a sampler, what's called a sampler bean, to Spring Cloud Sleuth so it knows how to send the information, or it knows to send information off to Zipkin. Without this, the sampler, the information would never be sent to Zipkin, wouldn't be stored anywhere. We wouldn't be able to go back and debug, you know, log requests or something like that. So we're going to create a bean here, and it's going to be a sampler, and return new always sampler. The always sampler, as you can probably guess from the name, basically is a sampler that's going to send everything, no matter what, to Zipkin. Now you can be more specific if you want. We provide other types of samplers, but for our demo purposes, it's going to work pretty well. And now, if I didn't mess anything up, we should be able to run this application and see a couple things here. The first thing you'll see, maybe not because this font is not going to be very big, but you can see here, if you have really good eyes, it says fetching config from the config server. So it's automatically fetching the config from the config server, and it's actually telling us what configuration it pulled down. It pulled down our greeting.yaml, which is the one we want, which is a great start to this. And it looks like everything's up and running on port 9090. So if I go to localhost 9090, we see hello, right? If you can't see that, there you go. So that's perfect. The other thing we want to check is to make sure, if we look down here, oh, I can make it bigger. Oh, look at that. All right, there we go. This is our logging information, right? We see that the greeting was printed out here. The important stuff is this stuff here. This is information that gets added by Sleuth, and this is the stuff that's going to provide a way of tracing requests through different microservices, right? So this is the name of the service, obviously, and these two numbers here is what's called a trace ID and a span ID. So a span, you can think of, you know, the span of the request through all the microservices, and the trace is that specific request in that service. In this case, they're the same because it's not traveling through anywhere. And then this value true here basically means we sent this to Zipkin. If we had a sampler that said I didn't want to send this log information to Zipkin, it would say false. Okay. Or if I didn't provide the sampler, it would say false. So it looks like that worked well. I'll also just show you here, if we go back to Eureka and make this much smaller, and I refresh this, we'll see that the greeting service now is registered here in Eureka, and here's the URL of it in the port. Also, if I take a look in Zipkin here, I should be able to see some tracing information popped up here, right? So we'll look at this in more detail a little bit later on, but we see that that worked too. All right, so we're off to a good start. Now on to our next service. Anyone have any questions about that before I go on? Okay. So new project. Here, we're going to do the same thing, except we're going to call this the name service. And we're going to basically, this is going to be almost an exact duplicate of the greeting service. So I'm going to quickly move through this. We need web, we need config, we need Eureka, we need sleuth, and we need Zipkin. Oops. Zipkin. There we go. Typing is hard. Next, and that's fine. New window, please. And again, like I said, every service should always have a name, so it feels loved. But really, because it helps out with configuration and Eureka, so we're going to give this the name. And we're going to do pretty much the exact same stuff in here. At enable discovery client, we're going to make it at rest controller. We're going to create a logger, private static, final logger, log equals logger, get logger, name application class get name. All right, cool. We're gonna pull the name value from the configuration. So at value again, name property. Okay, it's gonna be a string name. All right, we're going to again create the sampler bean. So public sampler, get sampler, return new always sampler. And then we'll also create a request mapping for this as well. So public string get name. Oops. We'll log this info name. All right, bear with me. I'm almost done. Return name. All right. So again, it looks exactly pretty much like the greeting service, but we're returning the name here. Okay. And if I didn't mess anything up in my rush to get that through, this should also produce some information. So again, actually this time I know that I can make it bigger, so we'll actually look at this. It is going off and requesting, talking to the config server. And again, you can change where this is happening, right? So by default, it looks at localhost *8088. Obviously, you can set that to be whatever the URL to your config server. And we see that it is pulling down the correct configuration file as well, which is great. And this should be running on port 7070, right? Yep. All right, so if we go to localhost 7070, we see the name. All right, great. We're almost there. All right, now it's something a little bit more interesting. Now we're going to create the service that's going to combine these two and serve up the actual greeting to us. So in this project, we're going to add a few more dependencies and some of the other ones that I talked about. So we'll just call the name of this application web. And again, we're going to add some of the same ones, right? So, try this again. Like this. All right. So we need web, we need the config server, we need Eureka again, we need sleuth, we need Zipkin. All right, those are all the same. We're also going to use ribbon. So we're going to bring in the ribbon dependency. We're also going to use feign. So we'll bring that in. And we're also going to use Zool. So we're going to, as an API gateway, we're going to bring that in too. Okay? So we have all those. And now we're going to go ahead and create this application. So Hystrix, like I said, I'm not going to specifically show you how to wrap things in Hystrix commands. It actually is used under the covers here in Feign and in Zool. So those, like for example, in your API gateway, every request that gets routed through your API gateway is actually protected automatically by a Hystrix command. I'm not really going to demonstrate that today, but like I said, if you check out my blog, I have a good post on using Hystrix commands directly as well as in Zool as well. And we can talk afterwards if you want. All right, so we'll give it a name again. There we go. And then from here, what we're going to first do is we're first going to register with Eureka. So we're going to say enable discovery client. And then we're also just going to add REST controller. And we'll again create a logger here so we can log some information for Zipkin, private static final logger equals logger.get logger web application.class.getName. All right. And then, so we're going to create a request mapping here. And we're going to call this, it's going to return a string, and it's called index here. And so we'll say string greeting equals the empty string for now. We'll log this, log.info. Greeting. Okay. Greeting. And then we'll return greeting. All right, so what we want to do is actually construct the greeting from our two other services, right? So we're going to want to make requests off to those services. So let's start by making a request to the greeting service. So one way to make an HTTP request, I'm sure everyone knows about, is to use a REST template. Okay, so let's start there. So we're just going to create a configuration class here. Static class myconfig, and we're going to create a bean. And this bean is going to be a REST template. And we'll return new REST template builder dot build. And we will go up here and auto wire that into our application class. All right, and now we'll create, just to break things up here, we'll create a private, if I can type, private string get greeting method. All right, that's going to say, return rest get for object. And if you remember correctly, our greeting service is located at localhost :9090, and it's going to return a string class. Oops. All right. Now, let's run this and just check this out for a second, and then we'll move on from there. It's always good to have checks to make sure things are working as expected up to a certain point. So, thank you. See? That's what I like to see, guys. Tell me when I screw up. All right, get greeting. Thank you. That would have been quite the exciting demo of returning the empty string. Okay. And come on, let's go. All right, so localhost :8080. All right, so that's good. We see hello. But the problem here is that we're just doing normal stuff here. We're just using the REST template. We're specifically calling the URL to the greeting service, right? I don't want to do that. I want to take advantage of service discovery because I don't really know for sure that service is going to be at that URL forever. I also don't know how many instances of that service are. What if there's 5 instances of that service and I can load balance between them, right? And take advantage of that. So one of the cool things we do in Spring Cloud to provide this routing as we talked about earlier, is we can enhance this REST template to take advantage of ribbon. So the only thing you have to do that is just add an load balance annotation to this, and that's it. Automatically is going to use ribbon. It's automatically going to take advantage of client-side load balancing, and that's it, all right? The other just small change we need to make here is instead of calling this URL specifically, we're going to say http://greeting, right? We're going to specify the name of the service, okay? And that's how it's going to know. It's going to say, okay, this is the name of service. I'm going to go to my service discovery service and see if I have a service named greeting. Great, I do. What URLs do I have for the service? It's going to pick one of those URLs and go ahead and make the request. You can also specify load balancing routing rules depending. It will automatically, by default, does round robin, but you can specify other ones if you want as well. So if we do that small little change and rerun the application, we should see the same thing. Oh man, I only have 10 minutes left. It must be moving slow. Okay. All right, so I am refreshing the page. It still says hello, so it is working. You can also see that in the logs as well. You'll see that ribbon was invoked here. There's some logging here about load balancer, getting the service name greeting, list of servers, etc. Right? So it is using ribbon. Now we also need to call the name service. And what we're going to do for that is, before I forget, I'm going to create one more bean here for our sampler. Sampler, get sampler, return, always sampler. All right, now we need to call new always sampler. Thank you. Pair programming. We're going to call, we want to call the name service now. Now I could use the load balance REST template to do that as well, but I'm going to show you a different way to do that, and that is to use feign. Now the cool thing about feign is that you can actually take advantage of WebMVC mappings or annotations to do this. So it makes it really easy to kind of get started. So we're just going to create a static interface that's going to describe the API that we're trying to call, right? So we're going to name service. There we go. And so we're going to say it's going to return our name service returns a string. We'll call it get name. And we're going to say @request mapping. And we just need to call the root, right? Because that's where our API lives. You know, if it was somewhere else, you'd slash whatever. And if it was a post, you can do post. You know, same stuff that you're familiar with the MVC annotations that you can do here. And then we just need to annotate this interface with and tell it that's a feign client and the name of the service that we want to apply this interface to, and that's the name service. Okay, that's the name that's registered in our service discovery service. And then the last thing we need to do is just enable feign clients in our application. Enable feign clients. That will automatically create a bean, so we can auto wire that name service into our application. And then we'll also go ahead and just create a method here, private string get name, and return name service dot get name. And I'm going to do one more thing before I restart the application, and that's I'm also going to enable Zool on this. So I'm going to say enable Zool proxy, and I'm also just going to quickly show you. Just going to disable this security so I can show you some of the routes. So if I refresh this here, I want to leave some time for questions. We should see, come on, go baby go. All right, we should see, hello Ryan. Oh, because I didn't add, come on guys, pay attention, pay attention. I gotta actually call the actual method I wrote, get name. All right, come on, I expect better out of you guys. All right. There we go. Hello, Ryan. Okay, great. All right. Thank you. Now, when I added that enable Zool proxy, it also added a couple routes to my application. We can see here all the routes from the service discovery service were added to my application. I don't really care about Zipkin and config server, but it might be interesting with the greeting and name service. So now I can automatically just go ahead and call those services right from this application. So if I go to /greeting, we see hello. If I go to /name, we see Ryan. I also didn't show you guys this before, but I'll just prove that everything's now registered in Eureka. And also, if we just quickly look at Zipkin here, I'm just going to change the time frame we're looking at here, so I'll make sure I get everything. Find traces. Let's look at the ones from the web service. We can see that the web service called the greeting service and the name service. We can see how long the request took. We can see various other pieces of information in here. Also really cool, and this doesn't look very cool now, but it would look cool if we had a million different microservices. You could actually see the dependency graph here. So if you Google, if you go Google image and type in Zipkin, you can find a whole bunch of cool pictures of like people who have huge dependency trees, and it shows up in here, which is really cool. And like I said, you can back this thing with Elasticsearch and Logstash and stuff like that, and do some nice querying for the data, etc. And with that, I have 5 minutes left. So, any questions? Sorry.
Just to understand, is the circuit breaker already active in this moment?
Yeah, so there is actually circuit breakers here with these routes in Zool here in the front end. If I was to kill the name service, for example, and kept on hitting it, it would actually trip the circuit breaker, and you can actually write fallback methods for these routes and return some static data. It would just require a little bit more work. But again, that's in our documentation because I wrote it, and it might not be good, but I know it's there. And you know who to contact if you have problems with that. So.
Hi.
Yeah.
A config client doesn't need to have access to the GitHub YAML, or does this config server does it give the config file to the client?
The config server gives the config client gives the configuration to the client. So like it's basically calling this API that I called right here and returning this JSON and passing it back. So the client doesn't need access to the back end.
GitHub or the file system, or
yeah,
okay.
or it just needs access to the server needs access to it, and you can secure the Git repo if it has a username and password. You can specify that stuff, etc.
Oh, okay. And the Eureka console, that one was the number of instances of the microservices.
Are you talking about here?
Yeah.
Yes. Yeah. So that's the number of instances. If there was more than one instance spun up, you'd see the number 2, 3, 4, or whatever, and then you see all the different URIs to that instance there.
Thank you.
No problem. Yeah. Yeah, you can just yell. Oh, okay.
What would it take to deploy that to the cloud now?
Deploy Eureka or what? This entire thing?
This whole entire thing now.
So, like I said, you're going to package these things up. They're just going to be jars, right? Or if you really want to use a WAR, go ahead. And then you can just run them wherever you want. I mean, if you're using Cloud Foundry, you can do CF push, jar file, deploy, right? We have, if you're going to use Pivotal Cloud Foundry, we have kind of productized many of these open source pieces here. So we have what's called Spring Cloud Services, which allows you to kind of deploy them a little bit more easier in PCF, but you can deploy them to AWS or wherever. It's just like deploying a regular application. There's nothing special you have to do here. All right. Yep.
Imagine that the greeting service is not mine, it's a third party. So I don't have control over whether it registers with my Eureka and does Zipkin tracing, stuff like that. How do I get everything that you have on the greeting service without being mine?
So if the greeting service is not owned by you, it's a third-party service, for example, you're not going to be able to integrate it with Zipkin and all that stuff, right? Because unless you somehow convince them to send their tracing information off to your Zipkin server, I don't know why they would do that. But you know, and you should not care about it, right? It's abstract to you. You don't really. It's not your responsibility. You depend on it. You can protect you can protect calling that service with circuit breakers, etc. So you can protect yourself from any possible issues in it. But you don't want to, you know, try to like bring it into your environment per se. Now you can, if for whatever reason you wanted to add a route to it, or like bring it into your client-side load balancer, so you could use something like Ribbon or Feign with that. You can. There's ways to specify add a entry to your client-side load balancer via configuration by specifying a URL directly instead of like having it send information to your Eureka server. You can do that. But again, you want to make, you know, your third-party services should just be opaque to you. It's not your responsibility. Protect yourself from failures with them, but you know, don't worry about collecting and logging information from them. Does that make sense? Does that answer your question?
Yeah, it does.
I can
Thanks.
talk to you more about if you want to like specify, you know, a URL that in your configuration that you can then call from a Ribbon or a REST template or Feign or something like that if you want to go down that path. Yep. That's also documented, by the way, how to do that.
Sorry, you know the annotation load balancer, it does more than load balance, doesn't it? It helps you find via a name.
Can you just repeat the question there?
Sure.
So, yeah.
Sorry, just load balancer there.
Yep.
It does more than just load balance, doesn't it? It helps you find the other service by via name.
Yeah, so if we go back and look at, I had a really quick diagram here of how this worked. Here. So you can see that the load balancer is actually pulling the some information from service discovery service. Again, you can take that service discovery service out of the picture and do this all via manual configuration.
Yeah.
And have it load balance that way. You can say I have, you know, these 5 instances and here are the URLs in a configuration file if you wanted to.
Okay.
So it's really opaque from the service discovery service, but if the service discovery service is there and it's enabled, it will automatically pull in the information from the service discovery service and route it via the name to the correct URL.
Okay. So where I'm just getting a bit confused about that then is you have the you know, the enable discovery service
Yes.
annotation or
Yep.
enable Eureka
Yep.
annotation, and you have a load balancer.
Yeah,
annotation.
but you don't have to. You can still use Ribbon and Feign without enable discovery service. Okay? The
Okay.
two are distinct from each other, but when they're both there, by default, we use the information from the service discovery service to
Okay.
route the request.
Okay.
Okay? And I think that's it, guys. If you want to grab me afterwards or reach out to me on Twitter or whatever, feel free to do that. Thanks.